Open up your books to page 239. Today we're going to be doing Lesson 17. Lesson 17 is on rates. To be more specific, we're going to be talking about unit rates today. A unit rate expresses the amount of something for every one of something else, which makes it really easy to compare things. Like yesterday when we were talking about speed, we found it was a whole lot easier to figure out speed, to understand speed, if we got the distance down to 1 unit of time. For example, 135 miles in 3 hours is harder to understand speed than 45 miles per hour. It's easier to understand 45 miles per hour than 135 miles in 3 hours. So that's why we use unit rates, getting things down, the ratio, one of the parts of the ratio, down to 1 unit. Let's look at number 1. Number 1 is a miles per hour problem. The double number line represents the ratio relationship between the number of miles and the number of hours that Blake rides his bike. What is Blake's speed in miles per hour? So I want the number of hours to be 1. Remember, I told you, whatever comes behind the word per, that's what you want to be 1. So if I'm looking at this double number line, I see that for 3 hours, Blake goes 45 miles. So I'm going to get 3 to be 1. To get 3 to be 1, I just divide. Three by 3. So since I divided 3 by 3, I have to divide 45 by 3. And that's going to give me 15. So Blake's speed is 15 miles per hour. And remember, per means for every one. So Blake travels 15 miles for every 1 hour. So basically what we did here was divide the first quantity by the second quantity to make the denominator 1. B says, at this speed, how many hours does it take Blake to ride 30 miles? All right, if he does 15 miles in 1 hour, then 15 times 2 is going to tell me how many miles he does in 2 hours. And 15 times 2 is 30. So Blake rides 30 miles in 2 hours. And then C says, at this speed, how many miles does Blake ride if he rides his bike for 5 hours? So 1 hour, 15 minutes. 15 miles. 1 hour, 15 miles. 2 hours, 30 miles. So if I just take the 15 and I multiply it by 5, because that's 15 miles times 5 hours, that's going to give me 75 miles. So Blake rides 75 miles in 5 hours. Number 2. The ratio table represents the relationship between the number of miles and the number of hours that Kelly rides her bike. Who rides faster, Kelly or Blake? Explain. All right, well, on Kelly's table, I see she goes 64 miles in 4 hours, and I want the number of hours to be 1. So I'm doing 4 divided by 4 to get that down to 1. And since I did 4 divided by 4, I've got to do 64 divided by 4, which gives me 16. So Kelly's speed is 16 miles per hour, and we can abbreviate MPH for miles per hour. And Blake's speed is 15 miles per hour. So Kelly rides faster. And you can see each time all we're doing is taking the first quantity and dividing it by the second quantity. So this was 64 divided by 4, which gave us 16. And then when you look at Blake, we did 45 divided by 3 to get 15. So when you're finding unit rate, all you have to do is divide the first quantity by the second quantity to get the denominator down to 1. So what you want to be 1 goes in the denominator. Remember, a fraction is division. When you see the division bar, when you see the fraction bar, just say divided by. All right, number 3. The double number line represents the ratio relationship between the total cost in dollars and the number of gallons of gasoline. A, what is the rate in dollars per gallon? Interpret its meaning. All right, well, I'm going to just say, all right, I want, let me look and see here. Behind the word per is gallon. So what I want to be 1 is the number of gallons. So I'm going to put the number of gallons in the denominator. But I'm actually just going to use, you can use any ratio or rate on the table. I'm going to use $27 for 10 gallons of gas because I can divide by 10 in my head. So I'm going to say 27 divided by 10, because that's $27 divided by 10 gallons. And what you want to be 1 goes in the denominator, right? And I want gallons to be 1. So 27 divided by 10 ends up being 2.70, $2.70. It is money. Make it go to the hundredths place. Don't forget your dollar sign. Money needs a dollar sign. So the cost is $2.70 for every 1 gallon of gas, or per gallon. $2.70 per gallon. And our unit rate there is 2.7, because what you're going to do now is use 2.7 to determine the cost if your tank is 26 gallons and you need to fill it up in C, and you're going to use 2.7 to figure out how many gallons of gas the driver buys in D. So 2.7 becomes your unit rate. It's like your conversion factor when you are converting units, like units of measurement. So let's do C. At this rate, what is the total cost to fill a 26-gallon tank with gasoline if it is empty? So you take the $2.70 per gallon and you multiply it by 26, because you got to buy 26 gallons. Folks, you can use your calculator on this one. 2.70, $2.70 times 26 gallons is equal to 70.20, and I go to the hundredths place because it's money. So the total cost to fill a 26-gallon tank with gasoline is $70.20. So the cost is $70.20. Then D says a driver spends a total of $24.30 on gasoline. At this rate, how many gallons of gasoline does the driver buy? So if the total cost is $24.30, I'm going to take that $24.30 and I'm going to divide it by the cost of 1 gallon, which is $2.70. You may use your calculator, and that equals 9. So the total cost, $24.30, divided by the cost for 1 gallon is $2.70 equals 9, means the driver buys 9 gallons of gas. All right, because of time, we're going to skip number 4. It's just the one I decided to skip. And we're going to go on to number 5. All right, number 5 is a graph, and the graph represents the ratio relationship between the number of cans of peas and the total cost in dollars of the cans of peas. Write a ratio that relates the number of cans of peas, so that's on your x-axis, to the total cost in dollars, which is on your y-axis. What is the rate in cans of peas per dollar? So we're going to write a ratio, and then we've got to write the rate in the cans of peas per dollar. So what you want to be 1 is the number of dollars, and then also we need to write the unit rate. All right, that's a lot of things. All right, so the ratio that relates the number of cans of peas to the total cost in dollars is 5 to 2. And that is peas to dollars. All right. Now, we need to next write the rate in cans of peas per dollar. So I want the number of dollars to be 1. All right, so here's my 5 to 2. If you can see that this point right here is 5 cans at $2. I want the dollars, the number of dollars to be 1, so that's going to be in my denominator. So my division problem is going to be 5 divided by 2. And 5 divided by 2 is 5 halves. And 5 halves is 2 and a half, but it's money, so, oh, I'm sorry, it's not, because 2 and a half is the number of cans per dollar. So it's 2.5 cans per dollar. All right. So the rate is 2.5 cans per dollar, and the unit rate is 2.5. So 2.5 is your unit rate, because you're going to use 2.5 to figure out the answers to the next questions. So B says, write a ratio that relates the total cost in dollars to the number of cans of peas. What is the rate in dollars per can of peas? What is the unit rate? All right, so a ratio that relates the total cost in dollars to the number of cans of peas, go back up, is 2 to 5, because now you're talking about the cost first and then the can of peas. So that's going to be 2 to 5. Now 2 to 5 is cost to cans. All right, now you need to know the rate in dollars per can. So now your word can is behind per, so you want the number of cans to be in the denominator. Okay, so that's going to be 5 is the number of cans, so that's going to be 2 over 5. All right, so 2 over 5 is a fraction, but we're trying to figure out the cost per can, and this is going to give us the cost per can. So we can't say it costs 2/5 of a dollar. So we got to change that to a decimal. So 2/5 is equal to 4 tenths. And 4 tenths is written like that to make that money, make it go to the hundredths place, put your dollar sign. So the cost per can is 40 cents per can. $0.40 per can. So then the total cost of 8 cans is going to be your 40 cents times 8. You may use a calculator on this one. And 40 cents times 8 is going to be 3.20. Make it go to the hundredths place because it's money. So the cost of 8 cans is $3.20. So D says, how many cans apiece can someone buy with $8? All right. Well, if you take the cost per can, so that's 2.5 cans times $8, because you can buy 2.5 cans per dollar. So 2.5 cans times $8 will give you 20 cans. So if you have $8, you can buy 20 cans. For $8. All right, folks, let's look at number 6. Suppose that a professional auto racer drives one of the world's fastest sports cars at its top speed. The graph represents the ratio relationship between the number of hours and the number of miles the auto racer drives the sports car. Assume that the auto racer drives the sports car at a constant rate. Based on the graph, what is the rate the auto racer drives the sports car in miles per hour? What is the unit rate? All right, so look for a spot where this diagonal line goes through both axes. So as I'm looking right here, I can see at 1 and 300, I have a point that goes through both axes. So there's one point. All right, and then at 2 and 600 is another point that goes through both axes. And then 3 and 900 is one more point. So based on the graph, what is the rate the auto racer drives the sports car in miles per hour? So miles, how many miles in 1 hour? I can look here and see 1 hour, because this is the number of hours, and 300 miles. So the rate the auto racer drives the sports car is 300 miles per hour. Based on the graph, let me shrink this up so I can see the graph. What is the rate the auto racer drives the sports car in hours per mile? All right, so now I just have to go and say, well, in 1 hour, the race car driver drives 300 miles. So that's, and I want to get the per mile, so I need the miles to be the denominator now. Hours per mile. So that's going to be 1 hour, and the number of miles is the denominator, over 300 miles. So your denominator, since you've got per mile right here, let me highlight it for you so you can see what I'm talking about, because I don't think I was clear on that. Per mile, right here. Let me increase this a little bit. Okay, so per mile means you want the number of miles to be 1. So the way I got 1 over 300 is the number of miles is 300. So I'm going to do 300 divided by 300 to get 1. And then the number of hours is 1 divided by 300, which is 1 over 300. So the number of miles is 1/300. So the rate the auto racer drives a sport car is 1/300 hour per mile. And then the rate is 1/300. And then C says, suppose you could ride your bike for 12 hours at a constant speed of 15 miles per hour. How many hours would it take the auto racer to drive the sports car the same distance? Okay, if I ride my bike 15 miles in 1 hour, then I'm going to ride 180 miles in 12 hours, because 15 times 12 is 180. If it takes the auto racer 1/300th hour to drive the sports car 1 mile, then it would take 0.6 hours to drive 180 miles, because 1/300th times 180 equals 180 over 300, which if you use your calculator, 180 divided by 600 is 6/10. Or if you simplified that fraction, you would get 6 over 10. So it would take the auto racer 6/10 hours to drive the sports car the same distance that I ride my bike in 12 hours. Okay, and if you want to know how many minutes that is, just take your time value and multiply it by 60. So 6/10 times 60 is 360 over 10, which is 36 minutes. So it takes you 12 hours to go the same distance it takes the racer, the auto racer, to go 36 minutes. All right, work that exit ticket and then do the practice and put your answers from the practice in the Google form. That's on Google Classroom.